want to talk about a problem that I put on the exam because we did things similar to this. Over the past week, but I don't know if we did anything quite exactly like it. And so on the exam, there's like a certain region that looks like this. It's kind of a like a parallelogram region, like this. So let's say this point is 1, 1, and then this point is 2, 2. Good morning. And this point is 2, 3, and this point is 1, 2. Okay, so those are like the corners of this parallelogram. If I wanted to make a double integral of some function with the order of integration dy dx, then x is my outside variable of integration for my outside integral. And so I'm going to let x be the constants. So x lower bound would be 1, and then my x upper bound would be 2. Okay? But for my y's, my lower bound for my y variable is going to change depending on what my x variable is, right? So my lower bound for my y variable would be x. And I say that because the lower bound of this trapezoid here is the line y equals x. Does that make sense?
What would be 2 in the 1 and 2?
Uh-huh.
From where?
Yeah, because the lowest value of x in my region is 1, and the highest value of x is 2. Okay. And then the upper bound for y would be what? Be what?
2.
It's not going to be a constant. It's got to vary depending on what x is, right? It's the top of this parallelogram.
It's not a rectangular region.
That's the line y equals x. That's the line that makes up the lower bound for my y variable. But what line makes up the upper bound for my y variable? Yeah, x plus 1. Exactly. So this line that makes up the upper part of my parallelogram, this line is y equals x plus 1. Okay? So that's, if I wanted to integrate some function over that region with the order of integration dy dx. But something weird happens. And like I said, there's a problem like this on your exam when you go in to take it this week. But something weird happens if I try to flip the order of integration to be dx dy. So let's talk about that. The lowest value I can take on for my y variable would be 1, right? And then the highest value I could take on for my y variable would be 3. So since y is now my outside integral, then the bounds would be like 1 to 3. But then if you turn your head and you try to look, what would be the lower bound of x? Well, it's actually a piecewise function for my lower bound of x, right? Part of my lower bound of x is just 1, it's just constant with respect to y. And then another piece of my lower bound of x is the line y equals x plus 1, right? Or I could rearrange this and say x equals y minus 1. Okay? And then the upper bound of x is also a piecewise function, where it starts out being the line y equals x, or x equals y. And then in this piece, it's actually just the constant 2 for my upper bound of x. And so you're much better off in this case making 2 double integrals where you have a setup like this. And in this first double integral, I'm just going to slice this region in half and think about my lower bound of x being the constant 1, and then my upper bound of x being y. My upper bound for my x variable is this line y equals x. Okay, so that integral takes care of this lower half of the parallelogram. And then for the upper half of the parallelogram, my lower bound of x is going to be the line y minus 1, or x equals y minus 1. And the upper bound of x would be just the constant 2. That gives me the upper half of this region R in there.
No, we can just multiply by 2 in the first one.
Well, whatever the function is in your integrand, I didn't tell you what the function is, but you could have some function of x and y that you're integrating. And that function might take on different values in the different places along this region, so you can't just multiply the first one by 2 now.
For the y, shouldn't it be from 1 to 2 and then 2 to 3?
Oh,
Oh, yeah.
yeah, that's a good point. That's a really good point. Thank you for catching that. So you're right. For the bottom part, the y value can only go up to 2. And then in the second double integral, the y value starts at 2 and goes up to 3. That's a really, really good catch, really important point.